All right, good evening all. You're welcome to today's tutorials with From Eternity the School Boy. Today we are going to take a look at review of our assignments on physics. We'll conclude the review of our assignment on physics. Today we stopped at question what? But you were here yesterday now. Sorry, the first day. We had the first day. Up to now, you don't have the question. Child. You have a question, right? On physics. The last assignment. We solved the question what? At least you put down the last question what that we solved. Dictate the question so that she can tell us the question number. Number what? 9. Okay. Chine, are you there? Yeah. Dictate that question so I can pick it from here.
Which of the following is equivalent to kilogram per second? A. Newton per second. Newton meter per second. C. Newton second. D. Joule per second.
Joule per what? Okay. The question number 10, still on units and the physical quantities, units and their dimensions. The question says, can you see the board from there? The question says, which of the following is the dimension of pressure? A, M per L per T squared. B, ML per T squared. C, ML squared per T cube. D, M per L cube. Now, solution. To answer this type of question, the first thing to do is to get a dimension of pressure. You get a dimension of what? Pressure. So if you get a dimension of pressure, we then check the options. Is it clear? Because the question says, which of the following is the dimension of pressure? So let us now get the dimension of pressure. Then we now check the correct options. Okay? Now, of course, if you are given a quantity, first of all, ask yourself this question. This quantity, is it a fundamental quantity or a derived quantity? If it is a fundamental quantity, you don't have any issue. Just simply do what? Go straight to the SI unit, and from the SI unit, you get a what? Dimension. But if it is a derived quantity, you need to understand, go to the formula of that derived what? Quantity. So from the formula of the derived quantity, you can now determine the units. Then from there, you determine the dimension. Because some of these derived quantities, their units may bear somebody's name. Like work bears joule. So if you're not careful, you become confused. For you to know what joule actually represents, what you do is this: you break down you go to the formula of that what? Of work. From there, you determine the what joule actually represents. Now let's go to the question. Let's solve this question. Pressure. Pressure is what? From the formula for pressure. Pressure is what? Pressure is what? Pressure is actually force per unit what? Area. Pressure is actually force per unit what? Area. So pressure is simply what? Force over what? Over what? Area. Force over what? Area. Now let's look at SI unit of force is what? Newton. Area is what? Meter what? Cube. But force is in Newton. Let's break down this force again. Are we together? To the component what? Quantities. that make up what? Force. By formula, force is actually what? Mass times what? Acceleration. Are we together? Force is mass times what? Acceleration. So now, this is now equal to what? Mass times what? Acceleration. Over what? Area. Are we together? Now look at this area again. In fact, let us not put area. Let us. Okay, no problem. Let's leave it like that. Now, having determined the quantities now, let us now go to the units of each of them. Are we together? Now, what is the unit of mass? Kg, right? Kilogram. Then the symbol is what? Kg. Times what of acceleration? Acceleration is what? Meter per what? Acceleration is what? Velocity over what? Time, right? Velocity over what? Time, right? Now, but by unit, by SI unit is what? Meter per what? Second square. Meter per what? Second square. Now we have meter per what? Second square. True of us. We are dealing with the units now. Acceleration is meter per what? Second square. All over area. Area is what is the unit for area? Meter cube. Are you following? Meter what? Cube. Sorry, meter square, not cube. Sorry, thank you. Meter what? Square. Is this blocking your view? So, area is meter what? Square. Now, remember in the dimension of these physical quantities, you try to bring them down to these three major fundamental quantities, which are what? Mass, length, and what? Mass, length, and what? Time. Mass, length, and what? Time. And by dimension, mass is what? Capital what? Mass is what? Capital M by dimension, right? Length is what? Capital what? L. While time is what? Capital what? T. So now let's look at this now. Let's look at this and change this unit to the what? This symbol, this unit symbols back to what? To what? Dimension. So we say that mass, which is kilogram, is what? M. So we have what? Capital M times what? This is meter, right? M is for meter, small m. The meter is what? Is for length. Meter belongs to what? Length. As kilogram belongs to what? Mass. Meter belongs to what? Length. And length is in dimension is what? Capital what? L. So we put capital what? L. This is S. S is symbol for what? Seconds. And seconds belong to what? Time. And time is what? Capital what? T. So we have times T raised to power minus what? 2. All over. This is what? Small m is for what? Meter. And meter is for what? Length, right? So length. So it's now what? L what? L what? Squared. True of us. L what? Squared. So now let's look at this now. So this length here is now L what? Squared. Now if this is L squared, what do you think will happen? Look at this in critically. What do you think will happen here? What do you think we need to do here now? Let's apply law of indices, right? Right? If you apply law of indices, everything should be in straight what? Line. Are we together? And for this to be in straight line, what do you now do? This now becomes equal to what? So this now becomes to what? We have M right here, right? M what? Next one is what? L. So L. This is L raised to power what? 1. Do you agree with me? Do you agree with me? Minus what? Minus what? It's 2 now. Minus 2, right? Minus 2. This is what? T what? Raised to power minus 2. So here becomes what? ml. 1 minus 2 is what? Minus 1. T minus what? T raised to power minus 2. So the dimension for pressure is m per L per T squared. So let's look at these options and take the correct option. Which one is the correct option here now? A. So A has the same dimension as what? Pressure. So the answer is what? A. M per L per T squared. M per L per T squared. Any question on this? Any question? Please, if you have any question, please feel free to ask, okay? All right. Okay, so this is the last question in this physics review. There's something I want to, let's solve this technical question. Then I think with that we can call it a day on this topic, on this review. Let's look at this question.